Scientists make the bold claim that they have discovered a brand new planet unlike any other. This planet is fascinating not only because of its size and location, but also because it emits light that appears to be artificial, according to NASA, which is known for its groundbreaking discoveries. Are we on the verge of discovering information that could fundamentally alter our perspective on the cosmos? Could this suggest that other planets may have life as well? We will soon discover the truth about this extraordinary light by looking at NASA's amazing discoveries. The Dawn spacecraft was launched in 2007 by NASA with the goal of examining some of the most intriguing objects in our solar system. Dawn set out on a journey that began with a 14-month investigation of Vesta, the second-largest asteroid in the belt, powered by 3 ion engines. Dawn sent back precise images and data that showed Vesta's complicated surface and varied geological past. Dawn began the second and possibly most exciting phase of its journey, a comprehensive investigation of the dwarf planet Ceres, after completing its mission at Vesta. On account of its particle motors, Daybreak had the option to leave Vesta's circle and head toward Ceres, something that customary synthetic impetus could not have possibly permitted. Dawn was able to travel great distances and enter a stable orbit around Ceres thanks to these Engine's gentle thrust. Giuseppe Piazzi, an Italian astronomer, discovered Ceres in 1801. It is the largest object in the asteroid belt that lies between Jupiter and Mars. Prior to its reclassification in 2006, it was regarded as the smallest dwarf planet in our solar system for a considerable amount of time. Ceres is the largest and most massive object in the asteroid belt and one of the most fascinating due to its distinctive features. Its diameter is approximately 950 kilometers. The first detailed images of this mysterious world, which showed bright spots all over its surface, especially in a big crater called a crater, were eagerly anticipated by scientists. The scientific community was immediately interested in and speculated about these bright spots. The Hubble Space Telescope's blurry, low-resolution image of Ceres was the best we had before dawn. The prospect of finally getting a close-up of this dwarf planet promised great discoveries because very little was known about it. The first light mission tried to work on how we might interpret the arrangement of the planetary group and the job of water in the development of planetary bodies. As with other asteroids, Ceres' bright spots could be made of highly reflective material, like salts left behind by sublimated water. This revelation proposed the chance of cryovolcanism on Ceres, an interaction where volcanoes eject fluid water or saline solution rather than liquid stone. In any case, what precisely are these puzzling lights, and what do they uncover about the idea of Ceres? Might they at any point be proof of continuous land movement or something significantly more remarkable? Due to its size, mass, composition, and potential to hold water and ice, Ceres stands out from other asteroid belt bodies. Dissimilar to ordinarily rough space rocks, Ceres has a more comet-like synthesis, proposing it could uncover more insider facts about the early planetary group. The Dawn spacecraft finally began its approach to Ceres at the beginning of 2015, marking an important milestone as it prepared to provide the first close-up views of the largest object in the asteroid belt. The Dawn spacecraft had been in transit for 2 years. Images of Ceres got more and more detailed as Dawn got closer, revealing a world that had been shrouded in mystery previously. The surface was cratered in the first images, indicating a long history of impacts. Scientists and space enthusiasts were intrigued by the mysterious bright spots in the gloomy, rocky terrain. The scientific community developed theories regarding the nature of these bright spots as the resolution of the images improved. Could they be something even more unusual? Or were they simply ice patches that caught the sun's rays? Mineral deposits and possible signs of cryovolcanic activity were among the speculations. A closer look revealed, to everyone's surprise, that the brightest spot was not a single spot but rather a group of several distinct spots. The most common explanation was that these were salt deposits formed when water sublimated. This suggested that Ceres had or still has some kind of geological activity that could bring brine or water to the surface, where it evaporates quickly and leaves bright, reflective traces. These findings cast doubt on previously held notions regarding Ceres and presented a picture of a world that was more dynamic and intricate than had been anticipated. The chance of the presence of groundwater or brackish water pockets could have significant ramifications for how we might interpret the potential for life in our nearby planet group. Ceres is a fascinating dwarf planet that is frequently described as an icy world with a rocky surface that is porous. Ceres stands out because of its distinctive composition, in contrast to the majority of belt asteroids, which are primarily composed of rocks and metals. Its surface is a combination of water ice and hydrated minerals, including dirts and carbonates, which give it a less thick design than its rough neighbors. This structure proposes that Ceres has a lot of water. It is more like a comet than an asteroid because of the ice and other volatiles that are trapped in its porous, rocky surface layer. The dwarf planet is thought to have a distinct interior that is made up of a muddy mantle and a core that is rich in water ice and makes up about half of the planet's volume. The rock and brine that make up Ceres' mantle probably surround a core that could be made of denser materials like silicates. If Ceres' core was heated by radioactive decay early in its history, then the presence of a significant amount of water ice suggests that Ceres may have hosted liquid water in the past. This interior design recognizes Ceres from its adjoining space rocks and brings up fascinating issues about its true capacity for geographical movement and the job of water in its advancement. But there's more. Ceres may have formed in a cooler region of the solar system and migrated inward after ammonia clays were discovered there. The existence of surface brines is supported by the possibility that the presence of ammonia lowers water's freezing point. Not only do these insights into Ceres' composition and history help us better understand this fascinating dwarf planet, but they also shed light on the processes that govern the formation and evolution of icy bodies all over the solar system. Cryovolcanism is a fascinating and uncommon geological process, particularly when contrasted with the more common volcanic processes that we observe on Earth. Cryovolcanoes, also known as ice volcanoes, are different from traditional volcanoes in that they release liquids like water, ammonia, or methane rather than molten rock. These substances can exist as fluids or gases in outrageous cold conditions, similar to where cryovolcanoes on Ceres are found. Cryovolcanoes on Ceres' capability by permitting water loaded down with broke-up salts to arrive at the surface. The salt water quickly sublimates when it comes into contact with the vacuum of space, changing from a solid or liquid state to a gas. Salt deposits that shine and reflect light are left behind by this. The enigmatic bright spots that can be seen on Ceres' surface are formed by these salt residues. The most popular of these brilliant spots is in a pit called a crater, known as a crater 5. Due to its high reflectivity and periodic hazes observed by the Dawn spacecraft, this region has received a lot of attention. Water sublimation is thought to be the cause of these hazes, which suggests that Ceres may still be experiencing or has experienced cryovolcanic activity in recent times. Ceres is home to a number of other bright spots in addition to a crater 5, each with its own distinct characteristics. Cryovolcanism may be widespread on Ceres because these spots are dispersed across the dwarf planet's surface rather than confined to a single location. These bright spots challenge previous notions that Ceres is a geologically inactive world by highlighting its dynamic and active nature. A wide variety of surface features began to emerge as the Dawn spacecraft returned more detailed images of Ceres. Numerous craters dot Ceres' surface, each telling a different part of the dwarf planet's history. Please share your thoughts with me in the comments section. Make sure to like and subscribe if you like the video.